What's good, everybody? My name is Mr. Peters. In today's video, we are going to be talking about factoring using the GCF. So, first off, GCF just means greatest common factor. And when we look in problem number one, right, let's write this on out. So, we use greatest common factor when we have a polynomial and that leading term, right? So, we're talking about 4n squared. When there is a coefficient in front of that leading term, right? So instead of it being n squared, a squared, b squared, we have a number greater than 1. This is when we can use the GCF. And when I look at this problem, what we're trying to do is to get the polynomial to have a lead coefficient of 1. So this is what I mean. So if we look at this problem, right, we could divide 4, 12, and 8 all by 4. That's its greatest common factor, a number that we could use to divide all three of these numbers. So when I pull this greatest common factor, right, that's the first step. We check for the GCF, we pull it. After we pull it, we need to go back and simplify the polynomial. And what that means is we're going to divide everything by 4 because that's what we took out. So now the problem turns into n squared plus 3n plus 2. And the reason for this type of factoring is to make it easier for us to factor. So now that I've done that, my focus is what's inside the parentheses. That's what I want to factor now. And it's the same thing. We're looking for factors that when we multiply, it gives us 2. And when we add, it gives us 1. So luckily for me, right, I know that that's going to be n plus 2, right, and n plus 1. And if you're asking why that 4 is out in front, it's a part of the answer. We pulled it out, and when we look at n plus 2 and n plus 1, after we multiply those back together, we have to then multiply it by 4 to get our final answer. So this is what we mean by when we say factoring uses using the greatest common factor. Now let's go into problem number 2. Let's speed it up a little bit. So problem number 2, we have 5x to the second power minus 15x minus 140. So I'm looking at these three terms, guys, and the smallest number is 5, right? So I'm saying to myself, okay, 15 and 140, we're going to see if they're both divisible by 5. So I checked for my greatest common factor, and I realized that I can divide all three of these terms by 5. So we're going to pull out our greatest common factor of 5. And then inside the parentheses now, right, we divide everything by 5. So we have x squared minus 3x minus 28. So now we're trying to factor what's inside the parentheses. So when we look at it, right, let's write our factors for 28. We have 1 times 28. I believe 2 times 14. 3 doesn't go into it. We have 4 times 7, right? And I think that's it for the most part. So when we're looking at this, right, we're saying to ourselves, okay, Mr. Peters, we wrote our factors out. How are we going to get a negative 3 in the middle when we add? We know it can't be 1 and 28, so we'll cross that out. It can't be 2 and 14, so we'll cross that out. And we're going to probably stick with 4 and 7. So remember, that greatest common factor we pulled out, it's still there. It's going to stay there. But it's just not our attention of focus. So on the outside, we have 5. And then now I'm going to break down this trinomial to the two binomials that multiply to get it, right? Okay. So we have x and 4, and then we have x and 7. And the next big question is, okay, what is my sign for 4 and what is my sign for 7? So we know when we multiply, we get a negative 28. That means one of the numbers have to be positive, one has to be negative. And when we add them, we're going to get a negative 3. So if we want a negative 3 when we add, our larger number 7 is going to be the negative number, and 4 will be the positive number. All right? So this is what we're talking about when we're talking about the greatest common factor. Now, In our next problem, I want to show you a greatest common factor where we're not just pulling out a number, we can also pull out variables, right? And I know it can get so complicated, but I got you real quick, easy explanation. So in this problem, we have 3a to the third plus 30a squared plus 63a. So another tip I want to give you guys is this. Just like we want that first leading term to be just a variable, a squared, b squared, understand that we want it to be squared to the second power. So if we have a leading term where the exponent is greater than 2, we may possibly want to pay more attention to it and pull it out. And this is what I mean. So when we look at this problem, right, I've noticed that I could divide each one of these terms by 3. But I also noticed that unlike the other two problems, that last term has a variable of a. So since all three terms have a variable of a, I could pull that out as well, right? So that means that each each term is going to have one less a. And this is what I mean. So 3a to the third. Once we divide by 3, it's just a to the third, and then we pulled out an a, so this turns to a squared. Same thing with our middle term. We divide by 3. This turns into 10. And then a squared, if we pulled out an a, now that is just 10a. And then in the last term, right, 63a, pull the a out, it's just 63 by itself. So after we divide 63 by 3, we're going to get 21, right? So please just understand, guys, when we're talking about the greatest common factor, we could also pull a variable as well. So now we're back to the basics. We're trying to think to ourselves, all right, we know that we're going to get a positive 21 when we multiply and a positive 10 when we add. So that lets me know that both my factors are going to be positive. And because we worked with 21 already, we know that it's going to be a plus 3 and a plus 7, right? But before we go, I'm going to ask that you guys smash the like button if you found this helpful. And I want to show you guys a very, very helpful tip of when you, another situation when it comes to factoring, okay? So this type of factoring is called slip and slide. So let's say we could not pull out a greatest common factor. So we went to the first problem, right? 4n squared plus 12n plus 8. So this is the same situation as the greatest common factor. We use this method when the first term is not just the variable to the second power, okay, like a squared, b squared. What we do is we take a and we're going to multiply it by the constant. So what this does is it changes the polynomial so that now that leading term is n squared. And then we have plus 12n. And then now this changes. Instead of plus 8, our answer is going to be 32, okay? All right, so now we have a regular trinomial, and this is why we use the slip and slide method. We want to have this first term, oops, made a little mistake. Let's just highlight it. We want this first term to be the variable to the second power, right? We don't want a number in front of it. So now I'm looking at this and I'm saying to myself, all right, let's factor 32. We're writing out all the factors that could go into 32. And we should know that it's going to be, let's see, I believe 4 and 8, right? So let's just double check. 4 times 8 gives us 32. 4 plus 8 gives us 12 as well. So I found my factors, right? I'm going to fill it in. So I have n plus 4 and I have n plus 8. But now the very tricky part with this type of factoring, guys, is we now have to go back and divide by the same number we multiplied by, which is 4, right? So we multiply by 4 at first. Now we need to divide our factors. We need to divide our factors by 4. So we're going to put this over 4, put 8 over 4. And this is the very important part. There's 2 rules. If we could divide evenly, we will simplify. So when we look at our first parentheses, n plus 4 divided by 4, we're going to change this to n plus 1, right? And then what we're going to do with the second one is the same exact thing, okay? We're going to divide 8 by 4. And once we do that, we'll get n plus 2, right? And, understand, guys, we still have that 4 on the outside, but this is just another way for us to factor when that leading term does not have a coefficient, or if the coefficient's 1. If it's greater than 1, we could definitely use this. So thank you guys for joining us today. We hope that you found our videos helpful today on factoring. Leave a comment down below if you're looking for any other videos in the future. And just want to tell you guys, thank you so much for joining us today. This is Algebra 1 with Mr. Peters.